For the most part, interactive website architectures will involve generating or dispensing data of one sort or another. You'll remember how back in our HTML section we spoke about collecting user input through web forms. That was fun, of course, but our simple example didn't actually go anywhere since it didn't connect with a database that would store the data for future enjoyment. We did just demonstrate how we can use Express.js to access CSV data from a web page, but the database is the real language of programmatic data management. So here's where we're going to fix that. The plan involves tossing some HTML, JavaScript, and the tiny database engine SQLite into a bowl, mixing vigorously and seeing what comes out. As you probably already know, the SQL in SQLite stands for Structured Query Language, which means that the syntax you'll use for interacting with an SQLite database will closely parallel how you do it in MariaDB, Amazon Aurora, Oracle, or Microsoft SQL Server. If you've got experience with any of those, you'll be right at home here. Why are we going to use SQLite here? Because it's a very popular choice for the kind of work you're likely to undertake in a web environment. Although, having said that, I got into some trouble many years ago while contracting as a Linux admin when I chose SQLite over the more robust MySQL engine for a particular project. Every case has its own special needs. At any rate, I've created a new directory on my Linux server along with some JavaScript files so I can show you how to create, modify, and delete records in a SQLite database. db.js will create a new table and add a single entry. db.add.js will add a second entry to the table. db.modify.js will change the details for one or two entries, and as you can guess, db.delete will remove an entry. I could incorporate all those actions into a single file, but I think this will make it easier to understand the code. Let's work through the code for each of those. We begin by loading the SQLite 3 module as SQLite 3, and then creating the db variable to represent our new database instance. The database will be called mydatabase.db. If there isn't a database using that name in our local directory, the code will create one. Otherwise, it'll just connect to the one that's already there. Since this is our first run, I'll create a new table within the mydatabase.db database. There'll be three keys in our table: ID, name, and age. As you can see, ID will be the primary key that we'll use to reference individual records. It'll work pretty much the same way our option column worked on the CSV you were playing with in the last clip. We'll define the data type of each key: integer, text, and again integer, here. This definition is something we only need to do once, but we do want to get it right because changing it later, after we've already added data, can be tricky. The next section will add a new record to the table. That uses the SQL command insert. You'll probably discover that official SQL documentation always capitalizes key syntax terms like insert and select. That's a useful best practice, but it's not actually necessary. As you'll probably see soon, when I'm quickly typing SQL commands, I'm way too lazy to bother. The query itself is templated as insert query, with the name and age details added as constants in the next lines. The db run method using the instant query constant and these two values as attributes is then run. Based on the success or failure of the operation, log messages will be generated. But hang on for a moment. What's with those question marks? And why do we need to break this process into two parts? This is actually an important security practice known as escape variable. With this in place, when the dbrun method executes the prepared statement, it'll automatically handle the escaping of the variable value, preventing SQL injection. When we're done, we'll properly close down the connection. Now, let's see how the modify code works. As before, we create a SQLite 3 constant and then connect to our database. This time, however, it'll already exist, so there's no reason to include the table creation code again. Instead, we'll go right to the modify section. The pattern is similar. We define an update query to update a record that we'll define. This operation will change the age value for an entry whose name equals John. You may recall that John's age earlier was listed as 25. We're going to update that to 30. Everything else will work the same as before, including closing the connection when we're done. The third file will delete a record. Whoops, I don't need this create section here. It's already done. I'll get rid of it. This code will delete the record where the name equals John. Let's make this happen. First off, I'll install the SQLite 3 module using npm. Next, I'll use Node to run the first file. Now perhaps you can guess why it is that connecting to the users table doesn't work the first time I run this code. But it works just fine the second time. But we can see that a new record has been successfully inserted. I'll list the directory contents so you can see the new mydatabase.db file that's been created. Now let's manually log into SQLite 3 to see how things might have changed. I'll reference the mydatabase.db file so we can open it up right away. I'll type .tables, and don't forget that dot, to list all the tables in this database. There's just the users table we created. Now I'll use the SQL command select to display a record. Here I'll use the asterisk to represent all records and specify the users table. We can see that record 1 containing John, who is 25 years old, has been created. Great. I'm going to run a fourth file that I didn't show you before that simply adds a new record to our table. That'll give us a bit of data to work with. The new record has an ID of 2. Next we'll run our modify code. We can now take another look inside the database. There are now 2 records, but look at how John has grown up so fast. He's now 30 years old. Finally, we'll run our delete code, which should remove John altogether. Another visit to SQLite will show us that there's now only a single record. I should note that the dbrun and dbclose format I use for those methods can also be referred to as database.run and database.close. It's just a matter of preference, or in my case, laziness. I'm a Linux admin after all, and the very best admins are in principle lazy. So that's it for covering the core objectives of this course. In the next clip, we'll spend a couple of minutes reviewing everything we've seen and talked about, and we'll talk about your next steps. Join me there.